Hello everyone. So in this video we are going to discuss about affine cipher. Affine cipher is another form of like substitution cipher. So we can say that it's like more secure than Caesar and shift cipher, but still it compromises its security. So it is extension of shift cipher. So what we are going to do in affine cipher, rather than just adding the key to the plain text, we also multiply by the key. So we have the key in two parts, like for example key k is equal to a comma b. So these both are a and b are two numbers which belongs to 0 to 25. And encryption algorithm says that ekx, where x is, you can say that x is the plain text. So this and we are going to produce the cipher text which is y. So x is the plain text and cipher text is y. So ekx is equal to ax plus b mod 26, where a and b are part of key. Similarly, the decryption, the cipher text x is equal to dk x a to the power a inverse y minus b mod 26. So first we will check that how this comes for the decryption. So for example, the cipher text y, we find this cipher text y with ex, and which is ax plus b mod 26. So what we can write? We can write here y minus b is equal to ax mod 26. Or what we can say? We can say that ax is congruent to y minus b mod 26. So if we multiply both sides with a inverse, so we will be getting a inverse ax is congruent to a inverse y minus b mod 26. And because this is a mod 26 operation, so a inverse is going to be 1. So x will be, how we can get x? X will be a inverse y minus b mod 26. So this is how we get the plain text again. So this is decryption algorithm. Now since the inverse of a is needed, because we need, like, to decrypt the message we need a inverse. So what we do, we choose a, we only choose the value of a for which GCD of a comma 26 is 1, for which GCD of a comma 26 is 1, because we need a inverse. So b can be can be anything, but GCD of a comma 26 should always be 1, and there are only 12 values that fulfills this condition. So key space is 12 into 26. We can, key space will be is to 12 into 26, it comes out to be 312. So again, it's more than the Caesar cipher or shift cipher, but still 312 is not a much large number. So exhaustive key search and letter frequency analysis can break this cipher. Similar to the attack the substitution cipher, like we do the attacks for substitution cipher, like in case of Caesar cipher or shift cipher, we check for keys or we check for frequency analysis. In the same manner we can do for affine cipher. So let's check a example of the affine cipher. So let me do it. So let's say the plain text is it's school. Plain text is it's school, and the k is, or it's given that encryption algorithm is 5x plus 8 mod 26. So what does it mean? It means a comma b, key a comma b is 5 comma 8. So GCD of 5 comma 26 is 1. So key is correct. Now how to write it? So let's say the plain text is, first write the plain text. Let's make a table for this. First write the plain text. It's cool. Now we are going to write x. X means the number which is equivalent to this plain text alphabet. We are going to write the number which is equivalent to plain text alphabet. So x will be I is 8, T is 19, S is 18, C is 2, O is 14 and L is 11. Now in the next line what we are going to do, we are going to calculate 5x plus 8. So this is x and 5x plus 8, this is going to be 48, this is going to be 103, this is going to be 98, this is going to be 18, this is going to be 78, again this is going to be 78 and it is going to be 63. In the next line we need 5x plus 8 mod 26. So let's calculate 5x plus 8 mod 26. So when we divide this 48 with 26, the remainder is going to be 22. In case of 103, the remainder will be 25. In case of 98, the remainder is going to be 20. For 18, the remainder will be 18. For 78, remainder will be 0. It will go 3 times. And for 63, the remainder is going to be 11. In the next line, what we are going to do? Now we are going to write the equivalent alphabet for these numbers. So now you can say we are going to write the ciphertext. So 22 is for W, 25 is for Z, 20 is for U, 18 is for S, 0 is for A and 11 is for L. So for each school, the ciphertext is going to be WZU SAAL. So as we discuss that we need A inverse. We need to decrypt this message, we need A inverse y minus b mod 26. So let's do it like decryption also. In the next, like what I'm going to do, I'm going to take ciphertext this and I'll show that how plain text comes out to be its school. So if we talk about, for this same example, if we talk about A inverse, because A is 5, so 5 inverse mod 26 is going to be 21. So it means A inverse y minus b mod 26 is 21 y minus 8, because b was 8 mod 26. So let me decrypt this. So for decryption, first we need ciphertext. So which is W Z U S A and L. And what is going to be Y for this? For W it is 22, for Z it is 25, for U it is 20, for S it is 18, for A it is 00 and for L it is 11. Now we are going to calculate Y minus 8. So y minus 8 is going to be 22 minus 8 is 14, 25 minus 8 is 17, 20 minus 8 is 12, 18 minus 8 is 10, 0 minus 8 is minus 8 and 11 minus 8 is 3. Now we are going to calculate y minus 8, 21 into y minus 8 into 21, I write it here. So 21 into y minus 8, so it is going to be 294. It is going to be 357, it is going to be 252, it is 210 and this is minus 168, again it is minus 168 and it is 63. Now we will calculate 21 y minus 8 mod 26. So 21 y minus 8 mod 26, it means when we divide 294 by 26, the remainder comes out to be 8. When we divide 357 by 28, the remainder comes by 26, the remainder comes out to be 19. In case of 252, the remainder is 18. In case of 210, the remainder is 2. For minus 168, the remainder is minus 12. And for case of 63, the remainder is 11. Now we know that we are working for all the numbers should be positive. So to make this 12 minus 12 as positive, what we are going to do? We are going to add again 26 into it. So it will be 14 and 14. So this is our numerical value for plain text, and when we get when we replace it, it is I, it is T, it is S, it is C, this is O and L. So that we get the same plain text. This is how we are going to encrypt and decrypt affine cipher. So encryption and decryption of affine cipher is a bit easy, but if you compare it with the with Caesar cipher or shift cipher, the classical substitution technique, it's a bit complicated, but again the cipher, it is it is breakable. We can definitely break it. Thank you.